In chapter 2, we spent an awful lot of time with the cout object. It is the way that we use, at least for now, to communicate to the user that an action is being undertaken on behalf of C++. So in order to do that, we had to use the output window. Out goes out to the output window. This is the opposite side of that coin. In 3.1, and this is starting on page 85, we have the cin object. Now, one might expect that if we have the cout, which is known as the insertion object with the less than, that the opposite side of that would be the cin object, or the extraction operator would be able to use the greater than, so that the those symbols work in the opposite direction. And you'd be right. This is one of those times that those primitive C++ and those primitive C-based gods were good to us when they named our like variable types, when they've named these insert and extract, and with cin and cout, they work in opposite directions of one another. That is conceptually pretty easy for us to be able to understand. There's just a couple of things I want to cover really quickly here in 3.1, and again, this is starting on page 85. The first thing I want to mention is and we can see this, we'll see it in code samples, and actually you've seen this already in code samples dating back to chapter 2, how it is that we would actually have this in the code. So I am not concerned about not having code out here for you alongside with this window. We can see it right here. This is figure 3-1. This is on page 86. We'll get rid of that. So we are in a cout statement. We are asking what is the length of a rectangle. And on the line that follows, we have cin, and then the extraction operator, and then length. What we're telling C++ here to do is, number one, we had to have already defined length as a variable before. So we would have somewhere, and I do mean this top to bottom, left to right, so up in this program someplace, we would have had to define our variable. So double length, for example, would be a variable declaration that we had to have beforehand for what you see right here in order for that to work. Now, what happens is when this line is executed, what ends up happening is the value is taken from the operator, I'm the operator, in the output window. So I would see that that line of text would come across, and it says, what is the length of the rectangle? And I would put something in, 4. And then that number, the 4, comes from my output window, and it's being extracted. It is going to be extracted, its value, 4, into that variable, which is length. So what'll happen is C++ already knows that when we did the run, so when we went through going from, our source code through compiling, through linking, and down into actual runtime, and we can see what we have in our output window. C++ has already gone, and over this way, it has set aside some space. It has set aside 8 bytes of space for my double, called length, and presently there is either nothing in there. If I said, double length equals 0, I would have initialized that value. I would have put a 0 in there. Or some of you are going to start to see this now in chapter 3 and 4, that if you do not assign an initial value, that C++ probably has some crap in there already. And we'll see that. I'm just planting the seed here for this for when we see it a little later in 3 and certainly in chapters 4 and 5. So over here in that location in storage that C++ set aside for a double, and that is being called length, we are going to take that value I took from the output window, that would be 4, and I'm going to assign it to that space. So from here on out, whenever the developer refers to length, and we use that in a mathematical operation, or whenever the developer refers to length and we do that in a cout statement, C++ is going to give to us the value that we read in from the terminal, from our output window, and that will be 4. Now, before we go on, I just want one bit of a programming tip here. For us, certainly, if we scroll down, we can see that right here, it's program 3-3. It's on page 88. And we can see that we are asking for, right here, you can see it in the output, enter an integer, a double, a character. And the user has to say, in this case, it's 4 space 5.7 space the letter B and then enter. No, in no way, shape, or form is this going to be what the user expects. Am I supposed to, as the user, enter an integer, hit enter, enter a double, hit enter, enter a character, hit enter? Am I supposed to not put a space between them because it doesn't tell the user to put a space between them? Am I supposed to sing a song or do anything else of the matter? And I know, as the beginning developer, you're looking at me like, surely there's only a couple of ways that we could interact with this program in order to enter an integer, a double, and a character. And you are absolutely right. But as the developer, it is your job, it's your job expressly to be able to lead a user to a good interaction. Might they accidentally stumble across hitting 4 space 5.7 space the letter B enter as the correct keyboard combinations that are going to get them through this interaction safely? Sure they might. It's not necessarily the first thing most users are going to enter, but they might. I suggest it is better programming practice, instead of having these on one line that the user has to enter, and remember what they're entering, is to separate these out. So ask to enter an integer and get that integer. On the next line, enter a double and get that double. On the line after that, enter a character and get that character. It's very much more difficult for the user to feel like they're alienated from what the process is, which means if they're not alienated, they're engaged in the process. And if they're engaged in the process, they can reasonably expect that their entries are of the right type that will lead them to the right outcome. That is what we're looking for here. So could you, like you see here in program 3-3 on page 88, simply have what we see here on line number 13 of their code, where I have a C in, I say whole for the whole number, fraction for the double, and letter for the character? Yeah, I could do that. Doing so, though, will lead to frustration. Better to break those out and ask for your inputs one at a time. It is a better programming practice. It barely takes any more time, and it leads to, in general, by all parties, less frustration.